We're going to take a look at, from Chapter 3, Section 2, questions 28 and 32, dealing with the variation of the data set. So for this, they want us to open up data set 4, and they want us to use the birth weights, column 7. And to go ahead and get these measures, we just need to use the descriptive statistics. We can get to that two ways. We can go under Data, Explore Data, Descriptive Statistics, or we can just right-click on the column and go explore this column. And right in the section right there is all of our measures of variation. And taking a first glance at the birth weights, they're all whole numbers. So when we round off, we're going to go out 1 decimal place. So for range, we have 4,600. For standard deviation, we have 693.4. And for variance, we have 480848.1. Now, we should be listing the appropriate units. And when I go to Appendix B and look up the birth weights are in grams. And the range is in the same units as the original data. The standard deviation is in the same units as the original data, but the variance is in squared units. So the variance is in squared grams. Again, this is why we don't talk about variance. It's in units that don't really make any sense. You can't really interpret a squared gram. Now, there does happen to be a second part of this question. They want us to go back and take a second look at the birth weights here. Now, they are all whole numbers, but all the 1's digits are zeros and all the 10 digits are zeros. So in reality here, what they want us to see is we're really dealing with things that are rounded to the nearest 100. So when it comes time to go ahead and round off our numbers, we're going to go one place value beyond. So one place value beyond hundreds is going to be tens. So our range, that's not going to change anything at all with the range. But with the standard deviation, that would change that to 690 grams. And that would change our variance to 480,850 grams squared. So again, one of the reasons for our rounding rule is to not give a false level of precision when we go ahead and compute these values from our original data set. Keep in mind, whoever we present this information to is not going to be seeing the raw data. So if we're going out much further in terms of precision than the original data, we're going to give an impression of that there's a lot more precision to our results than there really are. Now for question 32, they want us to go ahead and use the range rule of thumb to estimate the standard deviation. Well, I could sort this to find the minimum and maximum, but if I go ahead and bring up our descriptive statistics, we do have the maximum and minimum listed down in this section. So our estimate of the standard deviation is going to be 4,900 minus 300 divided by 4. That's 4,600 divided by 4. And that's going to go ahead and give us 1150. Now, from the data we're rounded correctly, and our units here are grams. And then they want us to compare the result to the standard deviation computed from all the data. Well, our computed standard deviation is 690 grams. Our estimate is 1,150 grams for the standard deviation. And not to pat myself on the back, but I did mention in class that the range rule of thumb has a tendency to overestimate the standard deviation, and that's what it did here. And one of the reasons that it can do that, or one of the occasions that it will do that, is because the range only uses the two most extreme values. In this case, our 300, that appears to be quite an outlier from where the bulk of our data is. So when you have outliers, that's going to go ahead and exaggerate the variation that we're actually seeing there. It does have an effect on the standard deviation, but it has an even greater effect on the range.